A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Two objects, each of mass m, are attached gently to the opposite ends of a diameter of the ring. The point here to note is they are gently attached, right? The ring now rotates with an angular velocity omega dash, right? Now let us see what it is saying. Basically, there is a thin circular ring, right? It was rotating about its axis with constant angular velocity omega, right? It was rotating with omega, and it was having a mass m and radius r, right? Now two objects, each of mass capital M, are attached gently to the opposite ends of a diameter. Let us suppose this is a diameter, right? Now they are attached over here, mass m and one mass m over here, right? They are attached gently, right? The ring now rotates with an angular velocity omega dash, that will be equal to, right? Now it is rotating with omega dash. So we have to calculate what will be omega dash, right? Now what is happening over here is, earlier it was rotating and now it is also rotating, but two now new masses have been added, so it was gently attached. So if I see, during this process no external torque acted there, right? There was no external torque, right? Earlier there was rotating with omega and they're gently placed, there was no external torque. That means what we can do is, if this is there, no external torque is there, then what I can do is I can conserve the angular momentum, right? I can conserve the angular momentum. That is why it was explicitly mentioned that they are attached gently, right? So we can conserve the angular momentum. So what is the angular momentum? Initially the angular momentum was I into omega, right? It was I into omega. Now what was I initially? It was, because it was a ring only, it was mr square into omega. Finally same angular momentum will be there. What will be the angular momentum now? It will be mr square plus two masses are attached at a distance r from the center, right? So that will be 2m into r square. This will be the total I into omega dash, right? So that means omega dash will be equal to m into omega divided by of m plus 2m, because r square will cancel out on both the sides. So that means this is the answer. So that means option C is correct. So that is the answer.